we can look at mixing colors using both the CMYK and the RGB values. Now, the trick is by watching a screen, you're definitely watching in red, green, blue, the color palette for additive colors. So this mixing, like it's paint, is a trick. The computer behind the scenes is calculating it. So one of these calculators, you can pretend you're mixing paint by going, what happens if I add 1 drop of yellow and I add 1, 2, 3 drops of red? Then I can boost it with a bit of, I don't know what that color is I'm clicking on right now. It's slightly off white to my eyes. And you can try mixing the different colors here. Now notice what you would call yellow, your computer printer calls star FFED00. These are codes and every color has an exact number that's this blend. So this would be a CMYK blend. This little color mixer here shows you what it would look like on screen, and it shows you these numbers. So color 0000, meaning no cyan, no magenta, no yellow, no black, is white. So white's number is 0000. In the RGB mode, it gets this coding, or it gets these. So your computers pass a color down as numbers. So let's suppose I grab the cyan and I move it up to 14. Now there's the color code that your computer would pass on, and you can see it's changing. So what if I add some magenta here, and then I add some yellow? In technical terms, I should be able to mix these three to a black, right? But you'll find no matter what you do, see, look at that, how close that came. Now here's the weird part. Adding yellow, you think it would become brighter, but you're adding paint. And so we get very close to black when we mix cyan, magenta, and yellow all at once. I'm having trouble here. So why then do we bother with a black slider? Well, let's see. I don't know if you could see it get any darker. I couldn't. If I remove these all the way down, okay, that black is really nice. I take these back and I recreate the black using this. It's pretty much hard for my eyes anyway to tell the difference. So these three colors of paint mixed together would give you black. Well, then why do we bother with a black cartridge on your printer? Think about it. When you have a color printer at home, if it did not have a black tank, it would have to use 3 separate colors like this to create the impression of black. Well, that would burn through triple the amount of ink. So it's very important that most of the time you're printing with black, they have a separate black cartridge. But technically, an artist could remake black by mixing these three. And to your eyes, whatever color you pick to create, whatever name you want to give it, like, I don't know, if you call that olive green, the computer doesn't. The computer calls it color 9603849 if it's intended for printing to paint, but it calls it 513081 when it's shown on this screen that you're looking at right now. So there's an example of how the color mixing works. Okay, so we can get any color in between, and I'm looking for the other mixer here. So here's one here. Let's suppose I wish to make the color white. Well, that's all red, all green, all blue. Well, for the printer is told 0000. Don't put any ink on the page to make what the screen shows. But let's suppose you happen to photograph a really lovely sunset, and where the sun is, there's this hue of color. Your camera sends to the computer, I picked up a signal 255.28.0. That's what you see on the computer screen. The printer has to try to translate it to what that color would be like in CMYK. And the printer does a math conversion and says, okay, to make this color that's on the screen, I need to use 89% of my magenta, no cyan, 100% yellow, and no black, and I should be able to print that color. Now, how many times have you printed a color off your computer and what was on screen and what came out on the printer were different? You suddenly get like a peach tone, or you get some sort of like your sunset turns to like that color. And this was a mistake between the conversion from the red, green, blue additive color scheme to the CMYK subtractive. The only way to pull that off is to get a calibrated monitor and a calibrated printer, and you pay for that. But if you see that color drift, this is the problem. The computer is converting between light on screen and paint with the printer. Now, is CMYK the only thing available? No. Really high-end printers may have 12 separate colors, and they will do a much better job of blending those colors. So I'm going to pause that here